Welcome to this deep dive, where we unpack the sources you're curious about. Today, we're heading close to home, cosmically speaking, near the Milky Way's core.
That's right. We're looking at Sagittarius C, which the studies you sent over describe as this really extreme, usually very active star-forming region. Loads of raw material there.
Exactly. Which leads to this, well, cosmic head-scratcher. Why isn't Sagittarius C popping with new stars? All that gas, you'd think it'd be a factory.
Uh-huh. But it seems to be, I don't know, holding back.
Yeah, precisely. So our mission today is to figure out why. We're diving into some excerpts, referencing a couple of really interesting studies. They just came out in the Astrophysical Journal, April 2nd, 2025.
Okay. And these are from researchers like John Bally at University of Colorado Boulder and Samuel Crowe at University of Virginia.
That's them and their teams, of course.
Yeah.
Okay, so let's set the scene. The galactic center.
Right, this area called the Central Molecular Zone, the CMZ. And the sources really stress it has this just immense amount of gas.
Immense. So naturally, you'd think, boom, stars everywhere.
You would. That's the logical assumption. Perfect conditions, right?
But, and this is where it gets really interesting, the research points out that the actual number of stars forming there is, well, surprisingly low.
Much lower than expected.
Much lower. So what's gumming up the works? What's stopping this gas-rich area from, fulfilling its potential?
And this is where the James Webb Space Telescope really changes the game.
Yes.
The studies make it clear. Webb gives us this unprecedented view. We're seeing details in Sagittarius C that were just, well, invisible before.
Totally. The teams Bally, Crowe, Ruben Fedriani, others, they used Webb's power to peer right in.
And Samuel Crowe apparently said Sagittarius C has a fundamentally different shape, a different look compared to other star factories. Way from the galactic center, anyway.
Yeah, and he links that directly to magnetic fields, which is the core idea, right?
It seems to be. One of the big discoveries is these long, glowing tendrils, hot hydrogen gas, sort of weaving through the region.
The studies called them like strands of spaghetti, didn't they?
Yeah, exactly. Kind of a weird image. But it gets the point across. These things stretch across huge distances.
So the hypothesis is powerful magnetic fields are threading through Sagittarius C.
That's the idea. And these fields are acting like a kind of cosmic brake.
Slowing down the collapse of the gas clouds.
Right. They hinder the gravitational collapse needed to kickstart star formation. So less stars are born.
Okay, and Webb's camera, the NIRCam, that actually shows evidence of this.
It seems so, because NIRCam can see in infrared. It pierces through the dust. And the sources say the images show these distinct bands of plasma.
Plasma.
Yeah, ionized gas. And these bands look like they've been shaped, sculpted even, by strong magnetic fields. It's like seeing the invisible forces at work.
Wow, okay, so you can actually visualize the magnetic fields effect.
Pretty much. It makes it much more tangible.
And John Bally apparently draws this bigger picture connection, comparing Sagittarius C to the early universe.
Yeah, he mentions the extreme conditions there, the high density of stars, the massive gas clouds. Might be similar to what things were like way back then.
So it's like a window into the past.
In a way, yeah. A natural laboratory for studying how stars might have formed when the universe was young and much denser. Maybe magnetic fields were even more important back then.
That makes sense. So comparing this to how we usually think stars form.
Right, the standard model.
Yeah.
Usually think of molecular clouds, maybe like the Orion Nebula. The sources mentioned Orion looks relatively smooth, kind of uniform.
And gravity just pulls everything together, things collapse, stars ignite. Simple enough.
Well, simple-ish. And then eventually, the new stars, their radiation, it blows away the leftover gas.
The region sort of self-destructs in terms of making new stars.
Exactly. Cuts off the fuel supply. Bally even notes our own sun probably formed in a big cluster like this, but its siblings are long gone, scattered.
But in Sagittarius C, it seems like these magnetic fields are messing with that first step, the collapse itself.
They seem to be interfering earlier, yeah. And actually, there's another study mentioned, led by Samuel Crowe.
Oh, yeah, focusing on the protostars, the baby stars.
That's it. They looked specifically at those young stars within Sagittarius C. And their data shows how these infants are, already active.
How so?
They're ejecting radiation, blowing out gas and dust, carving little bubbles around themselves.
So star formation is happening, just maybe slower overall, and the young stars are still doing their thing individually.
Seems like it. It's complex. You have this large-scale suppression, potentially from magnetic fields, but the stars that do manage to form are still energetic.
Which brings us back to that structure. Not smooth like Orion, but filamentary, those spaghetti strands.
Right, and finding dozens of these bright plasma filaments, some stretching for light years. Ruben Fedriani apparently found that quite surprising, unexpected.
Just highlights how much Webb is revealing that we didn't anticipate.
Absolutely, and the research suggests a major reason why Sagittarius C looks so different, why it has these filaments,
Yeah.
is the big guy downtown.
You mean the supermassive black hole at the Milky Way center?
Exactly. Its gravity is immense, obviously, but it also influences the gas swirling around it. That motion can amplify magnetic fields.
Ah, so the black hole helps crank up the magnetic field strength in that whole central region.
That's the connection the studies make. This amplified field, much stronger than what you'd find out in the galactic suburbs like near Orion, is what shapes the plasma into those weird filaments.
So location, location, location. Being near the galactic center makes all the difference because of that stronger magnetic environment.
It really seems to.
Yeah.
Which leads to this idea of the twilight of Sagittarius C.
Sounds a bit ominous.
Well, yeah. The prediction is that its main phase of star formation is kind of winding down.
Because the stars that did form have already pushed away a lot of the gas, like we discussed earlier.
Partly that, yeah. They've dispersed a good chunk of the original molecular cloud. The magnetic fields might have slowed things down, but star formation wasn't completely stopped.
So the nursery is running out of material, or at least accessible material.
That's the picture. Valley apparently said the whole nursery could basically disappear, fade away, in just a few 100,000 years.
Astronomically speaking, that's nothing. A blink of an eye.
Pretty much. Almost the end of the story, as you put it.
Okay, so let's wrap this up. What are the big takeaways from this deep dive?
Well, first, Sagittarius C, seen like never before with Webb, is this stellar nursery where things aren't quite going according to the standard playbook.
Right. Powerful magnetic fields seem to be playing a much bigger role than we might typically assume, slowing down starbirth.
And this offers us this amazing, maybe fleeting glimpse into conditions that could have been common in the early universe. High-density, strong fields.
Plus that really striking discovery of the filamentary structures, the plasma spaghetti.
Yeah, totally unexpected. And directly linked, it seems, to that intense magnetic environment near the galactic center, making it fundamentally different from places like Orion.
It really makes you wonder, doesn't it? If magnetic fields are this important here, slowing down starbirth near our galaxy's heart, what else are they doing?
Exactly. What other cosmic processes might be more influenced by magnetism than we currently give them credit for?
It forces you to think about that cosmic balancing act, you know? Gravity pulling things together, magnetic fields potentially pushing back or redirecting. It's clearly not just gravity running the whole show.
Definitely not. There's this whole interplay, this tension between forces shaping the universe in ways we're only just starting to fully appreciate, thanks to tools like Webb.